All right, starting on the word problems. A boat sailing parallel to the coast sights a lighthouse. So here's my boat. Here is the lighthouse, and my boat is sailing. He's 14 degrees from its direction of travel. So my boat is right here. Look at him. And here is my lighthouse, which I will not draw. Okay, so when he sights it first, he sees that he is at an angle of 14 degrees. Okay. 4 miles later, he tracks it again, and he finds out that he is at an angle of 25 degrees. So our triangle looks like this. And I know that this is 14. I know that this is 4. I know that this is 25. So 180. 180 minus 25 is going to give me 155. This is 155 degrees. Okay, so I would like to know how far is my boat from the lighthouse. I want to know this side. Okay, so do I have a completed ratio? Yes, I do, because I've got two angles of a triangle. So 180 minus 155 minus 14 gives me 11 degrees. So that's 11. So I do know that I've got a completed ratio, so I'm going to use the law of sines. So the sine of 11 over 4 will be the same ratio as the sine of 14 over x. So the sine of 14 over x, so I'm going to cross multiply. X times the sine of 11 is 4 times the sine of 14. And then divide both sides by the sine of 11. And I get that my boat is 4 sine 14 divided by the sine of 11 is about 5.07 miles away. Make sure you're in degrees. 5.07 miles away from the lighthouse is what this distance is. So let's do 46. We have the current in amperes produced by an electric generator is given by, that is the current in amperes, and it's given by 40 sine of 60, cross that out, equals 40 times the sine of 60 pi t minus pi over 2. 60 pi t minus pi over 2. And I want to find out where t is the time measured in seconds. Please find the smallest value of t to the nearest thousandth, for which the current is 20 amperes. So my current is 20 equals 40 times the sine of 60 pi t minus pi over 2. So I'm going to divide both sides by 40. So I get 1/2 is the sine of 60 pi t minus pi over 2. So I'm going to take the arc sine of both sides. So the arc sine of 1/2 is going to be pi over 6. So pi over 6 is the arc sine of these two things reduced to each other, which means I get 60 pi t minus pi over 2, and I'm going to solve for t. So I'm going to add pi over 2, so pi over 6 plus pi over 2, and then I'm going to divide both sides by 60 pi. Make sure you put that in parentheses. So pi over 6 plus pi over 2 divided by parentheses 60 pi, or it will screw up your order of operations, gives you an answer of 0.01111. So my time is 0.011 seconds. Sure, seconds. Okay. All right, so now we have a 25-foot ladder, just reaches the top of a building. So I know that this is 25 feet, and it forms an angle of 41.5 with the wall. So that's 45 degrees, and we are assuming that our building is at 90 degrees. Okay, so the question is, do I have a completed ratio? Because if I do, I can use the law of sines, which I do. This is 90 degrees, this is 25. I do need to know that angle measure. So 90 minus 41.5 gives me 48.5. So this angle is 48.5 degrees. And so I want the sine of 90 over a length of 25 should have the same ratio as the sine of 48.5 over y. So I'm going to cross multiply. So I've got y times the sine of 90, and the sine of 90 is 1, is 25 times the sine of 48.5. So divide both sides by the sine of 90, which is 1, and I get 25 times the sine of 48.5 is 18.72 feet. So this height is 18.72 feet. All right, two airports are 150 miles apart. So here is an airport, and here is an airport. So this is airport 2, and this is airport 1, and they are 150 miles apart. And flying from one airport to another, the pilot sets a heading that's 11 degrees off course. So this is going to be 11 degrees right here, off course. Okay, after 15 minutes, the pilot corrects the error. If the average speed of the airplane is 200 miles per hour, so if he goes 200 miles in 1 hour, then he goes 50 miles in 15 minutes. Okay, 200 miles per hour means he goes 50 miles every 15 minutes. So I know he's gone 50 miles in a slightly offwards direction. Okay, I would like to find out what angle does the pilot move to correct the heading, and how many miles was the plane off to get from the second airport. So I'm looking for, I need to find this angle because he's got to re-steer, okay, and I need to know this distance. So first of all, let's find a completed distance. So I have got side angle side, which means I don't have a completed ratio. So I'm going to have to use the law of cosines. So I do have, if we just say that this is A, then this is little a. So I'm going to use A squared is B squared plus C squared minus 2BC times the cosine of big A. So A will be the square, are you kidding me? Will be the square root of, let's see if this works. Oh no, it's purple, it's black. All right, so I just took the square to both sides because the square root of A squared is A. So I got 50 squared plus 150 squared minus 2 times 50 times 150 times the cosine of 11 degrees. Make sure that you are in degrees. Shall we check? We are. Okay, so the square root of 50 squared plus 150 squared minus 2 times 50 times 150 times the cosine of 11 degrees gives me a length of 101.37. So this length right here is 101.37 miles. So how does he need to correct? Okay, so I'm going to use the law of sines now, and I'm going to find this angle, which I'll have to subtract from 180 to find out how far he had to steer over. Okay, so the law of sines says that I've got the sine of 11 over 101.37 equals the sine of 150 over, what did I just do? I just went backwards. I am so sorry. That's the sine of B over 150. I'm like, what is going on? All right, so that's a side length. It's not an angle measure. Okay, so the sine of an angle measure to its side will be the same as the sine of this angle measure to that side. So I'm going to cross multiply. So I get 150 times the sine of 11 is 101.37 times the sine of B. I'm going to divide both sides by 101.37, and then I'm going to take the arc sine. So the arc sine of this will tell me that angle measure. So the arc sine of 150 sine 11 divided by 101, that mess, okay, gives me 16.4. So he's got to swing 16.4 degrees. Okay? So, hang on, I'm thinking, because I told you you had to subtract. But you're finding parallel lines. So it's 16.4. All right, so we need to, I'm going to skip number 49 and come back to it just because it's a little intense. So we're going to do 50 and 51. Okay? So number 50 says, given the displacement of an object. So I have D equals 4 minus 5 times the sine of 3t. Okay? 4 minus 5 times the sine of 3t. That is going to give me, hang on, back up, just because I kind of skipped over that for a second. If I have this line right here is parallel to this line, then this is the transversal. Okay, so when I found that, I found the angle measure that I needed. Okay. Anyway, so I want to know what kind of motion this is. This is simple harmonic. Okay, and I'm going to rewrite this so it's a little bit more familiar. I've got negative 5 times the sine of 3t plus 4. Okay, so it's simple harmonic based on our definition of simple harmonic motion. I would like to know what is the maximum displacement from its resting point. So the maximum displacement would be the amplitude. So your amplitude is 5. Remember that that just means it got pulled down first. Okay? It means it's going in a downwards direction. But your displacement is 5. It's not negative 5. Okay? What's the time required for one oscillation? So an oscillation is going to be the period. So I can find the period by taking 2 pi over b is the period. Well, what value do I have for b? I have 3. So my oscillation is 2 pi over 3. Okay? And then it says, what's the frequency? So the frequency means if you left your period at 2 pi, how many times would it go back and forth? Flip this and you're done. So my frequency is 3 over 2 pi. Okay? 3 over 2 pi. So honestly, I think that's a good spot to stop, and then we'll come back and finish off with one more video.